Okay, this one is mission 6 or vertical takeoff and landing for AV8B Harrier. And this one we will do the actual vertical takeoff and go away from the hover.
Welcome to this training mission, where we once again find ourselves in the warm-up area, and in which we will perform vertical takeoff and landing, or VTOL. We will cover both press-ups and full accelerating transitions into forward flight, and conclude with a decelerating transition into a vertical landing. Although a vertical takeoff is considered the easiest type of takeoff, there are a number of insidious flight characteristics that must be anticipated and accounted for. It is important to remember that the aircraft was designed to land vertically, and therefore should be smooth, easy, and require low workload as long as the aircraft is properly trimmed. The first rule of vertical takeoffs is to always take off into the wind. The second is to always take off from flat terrain so that you minimize the use of your reaction control system, or RCS, and adversely affect your engine performance with bleed air and hot gas reingestion. Let's begin by conducting our C waiver pre-position checks. For brevity's sake, we are only going to cover the steps relevant to this flight, but for a complete explanation of these checks, see the previous training mission on short takeoffs or landings, or STOL. First, set the clock by pressing the timer, or TMR button on the UFC. Select TTT with ODU2 and then press ODU1 and verify that the clock shows 8 AM. Next, press ODU5 and check that the UTC time shows 4 AM. Verify that this is the same as the time shown in the cockpit watch and on the HUD. At this point, you could also set the desired time on target, but we don't need to do it for this sortie. Set your FLIR by pressing Menu, push button 18, and then FLIR, push button 1. Set the mode to black or white by pressing push button 20. Set up your TACAN by pressing the TCN button. Enter 6-7 on your scratch pad for Cabaletti and press Enter. Next, turn it on by pressing the On-Off button. You will notice a small TACAN symbol appearing next to your aircraft on the left MPCD. Set up your video recording system by setting your VRS and MFCD/HUD switches as desired. Confirm that your canopy is locked and that your canopy close light is extinguished. Make sure that the ejection seat is armed by checking that the ground safety control handle on the right side of the seat is closed and pointing down. Recheck that your standby instruments match. Place your altitude, or ALT switch, in the radar, or RDR position. Make sure that your INS knob is in the IFA position to ensure a tightly coupled GPS and INS throughout your flight. Turn your approach light on. One thing which is crucial to remember for vertical takeoff and landing is the weight of your aircraft. In order to successfully do both, it cannot exceed 20,500 pounds. You can use the aircraft's onboard systems to check your weight or do the math yourself. The details you need for the latter are listed in your kneeboard. On the right MPCD, select Menu on push button 18. Next, select VRST on push button 8. OK, now box either vertical landing, or VL, on push button 6, or vertical takeoff, or VTO, on push button 7. Good! Our aircraft weight is listed on the gross weight, or GWT, readout at the bottom of the list. Please note that you can press the ODU button 1 to have this number displayed on your UFC. Do it now. Next, we will begin our takeoff checklist, or finger checks. The first check is a 1-finger configuration check, followed by either a 2-finger dry acceleration check or a 5-finger wet acceleration check. Let's start the 1-finger check. Press the VSTOL Master Mode button to colonize the ODU with VSTOL options. Setting the nozzle rotation airspeed is not required for vertical takeoffs. Select Pitch Carrots or PC with the ODU button 2 and verify the default setting of 14 degrees on the scratch pad. This sets the pitch carrots to 6 degrees above the horizon, where we will seek to place the depressed attitude indicator, or witch's hat, for an accelerating transition into wing-borne flight. Ensure the STO stop is clear and fully aft. Trim the stabilator to 2 degrees nose down. Set flaps to stall, observe 25 degrees in the flaps position indicator, and verify that no warning, caution, or advisory lights are illuminated other than droop, which can be on. During the takeoff, you will have to maintain a nozzle angle of 25 degrees or greater while in stall flaps.
Nozzle angle or flaps angle?
Select Menu on the right MPCD using push button 18 and select Engine on push button 11. Set the nozzle lever to 50 degrees and verify that the engine display panel matches the HUD. Verify that the flaps adjust to 62 degrees and that the flaps indicator matches the HUD with the droop light illuminated. Reset the nozzle lever to 10 degrees. Prior to conducting our additional finger checks, determine which vertical takeoff maneuver you intend to perform. There are two types. The first is a press up, which is a vertical takeoff into a hover, followed immediately by a vertical landing in training. This is designed to familiarize yourself with the handling characteristics of the Harrier in a hover. But a variation of this technique may also be useful for arresting a vertical takeoff and then pedal turning into an accelerating transition that is not coincident with the prevailing winds. The second is a standard vertical takeoff, followed by an accelerating transition into wing-borne flight. Select the type of maneuver you wish to practice. 1 for VTO, hover, and then VL, that's a press up, or 2 for VTO accelerating transition, or VTO Excel.
Capoletti, Dodge 1. Request taxi to runway. Dodge 1. Capoletti, clear to taxi to runway 25.
When cleared for takeoff, steer into the wind. Apply the brakes to come to a stop. From this position, we will conduct 5-finger Excel checks and immediately transition into our takeoff roll. We covered 2-finger dry acceleration checks in the short takeoff and landing, or
Let's go to the runway, and I will try to align with the wind, which means heading 29, 290.
Dodge 1. Unable to clear for takeoff. Dodge 1. Capoletti, you are cleared for takeoff when ready. Climb 300 at QFE 29.86.
Okay.
press the Excel or push button 16 on the engine page on your right MPCD. Advance the throttle to just above 60%, then reduce power to maintain 60%. The aircraft will time how long it takes for the engine to spool between 35% and 60%. Verify that this value is between 2.4 and 3.1 seconds on the engine page. Arm the water switch to takeoff, or TO, and note the RPM rise by 6% to 7%. Reset the RPM to 60%. Next, place the nozzles at 30 degrees and check the duct pressure. Once verified, set the nozzles for takeoff at the hover stop, or 82 degrees. On the left MPCD, select EHSD with either push button 2 or sensor select switch left. On the right MPCD, select FLIR with sensor select switch right. 5-finger checks are complete. Keep the anti-skid switch in the skid position. You are ready to initiate your takeoff. Wait to do so until I have finished explaining the steps and give the command. Hold the brakes until you are airborne. You will initiate the takeoff by throttling up to full power in one smooth motion. Check your top end RPM in that you have positive water flow. Immediately counteract any developing roll or bank angle, keeping the wings level, and scan left and right to ensure there is no sideways drift. Refrain from pulling on the stick unless forward speed is developing, as hot RCS gas from the nose will raise temperatures and reduce engine performance. You will learn to predict the necessary inputs with practice. As you pass 50 feet, set your accelerating attitude by placing the witch's hat at the pitch carrots, and begin nozzling out simultaneously, such that the nozzle angle with relation to the ground remains unchanged. You will center the wind vane and V-stall side slip ball in the HUD, preferably by looking through the V-stall ball at the wind vane, using the rudder pedals prior to reaching 30 knots, and remain wings level while gradually reducing nozzle angle further. Once established in wingborne flight, reduce power and complete the nozzle out to fully aft or 0 degrees. Maintain climbing flight and ensure the velocity vector does not descend below the horizon bars in the HUD. Seek to maintain between 12 and 14 units of AOA with the nozzle handle until established in wingborne flight. Ready? Alright, initiate the takeoff by adding power to full throttle. When you start to lift, keep the wings level. Monitor your climb rate and altitude. You pass 50 feet, so start to pull back on the stick and nozzle out slightly. Put the witch's hat on the pitch carrots and center the wind vane with the rudder and monitor your acceleration. As you accelerate, begin to gradually nozzle out by adjusting your nozzles to maintain 12 to 14 units of AOA until you are under wingborne flight. When in wingborne flight, nozzle out gradually to full aft, to 0 degrees, and remember to set your flaps to auto prior to nozzling past 25 degrees. Maintain wings level until you pass 120 knots. Good! You're in wingborne flight. Reduce the power to achieve the normal lift dry rating, and let's move to the after takeoff checklist. Place your landing gear up. Ensure your flaps are in auto. Ensure you have nozzled out to fully aft, or 0 degrees. Set the water switch to off. Check that the stow stop is clear. Press the nav master mode. Alright, turn and fly to waypoint 1. Climb to 5,000 feet and do not exceed 300 knots. Once you get there, engage the AFC and altitude hold switches and enter orbit. We will continue once you arrive. You did well enough on your takeoff. Now let's cover the vertical landing. There are several things to keep in mind, so please pay attention. First of all, the weight. Just like with takeoff, your aircraft's weight cannot exceed 20,500 pounds to conduct a vertical landing, or VL. Since in most combat missions you will carry enough ordnance to get you over this weight limit and prohibit a vertical takeoff, before you commence your approach you will need to ensure you are below this weight by dumping or burning fuel, jettisoning or expending ordnance, or some combination of the two. If your aircraft exceeds this weight by as much as 4,000 pounds, you may conduct a rolling vertical landing, or RVL, as fast as 70 knots at touchdown, in order to augment your engine power with lift generated by the Harrier's wings. Weight won't be a factor during this sortie, but you have to always keep it in mind during normal recoveries, especially when coming back to the ship, where an RVL is not an option. Second, VLs and RVLs may be conducted from the standard pattern or a straight in, but use a decelerating transition into jetborne flight. In a way, this is a reverse of what you just did in the accelerating transition, except that you won't have a positive check that you have the performance you need until you're in jetborne flight, after your wings have stalled and it could be too late. You'll perform the before landing checklist and then aim to arrive at the key, which is located approximately half a nautical mile or 3,500 feet from your designated landing spot at an altitude of approximately 325 feet AGL. The key places the landing spot on your HUD pitch ladder 5 degrees below the horizon. Once you reach the key, you will set a correct attitude by placing the witch's hat on the horizon and moving the nozzles to hover stop position between 81 and 83 degrees. After that, you will maintain a shallow glide slope of 3 degrees to arrive over and slightly offset, or abeam, the landing site. Then, maintaining altitude of at least 150 feet AGL and a speed below 30 knots, you will cross over to the landing site and enter hover. Finally, you will commence the vertical landing from the hover at around 50 feet AGL. You will find a list of required actions in the kneeboard. When ready, turn towards waypoint 2. It is located at the position of the key, 3,500 feet from the landing spot. Alright, when ready, exit orbit and fly toward waypoint 2. Do not exceed 300 knots indicated. Alright, we will start with the landing checklist. It is the same for all landing methods. Reduce your speed to below 250 knots. Once below 250 knots, lower your landing gear. Enter VSTOL Master Mode. Next, make sure that your nozzles are set to 25 degrees or more, and set the flaps to STOL mode. Check that the stow stop bar is clear. Check for positive duct pressure and for at least 2,700 psi brake pressure with pedals depressed. Set the water switch to landing, or LDG, as required. If your plane's weight is close to the limits, you will generally want to enable the water flow as a precaution. To check for proper water flow, set the nozzles to at least 60%, place the water switch to takeoff, select full throttle to 105%, and verify the green water flow light illuminates. When the check is complete, reset the water switch to landing. Set your video recording system to run. Check that there are no warning or caution lights illuminated. Set the lights as required. Normally, you'll want to enable your position lights, anti-collision lights, and landing light. This concludes the before landing checklist. Now continue flying towards the key. It has been marked with green smoke for your convenience. Set the nozzles to 60 degrees and keep the AOA between 10 and 12 units. You will want to arrive over the key at exactly 325 feet AGL.
This will be interesting.
You are now over the key. Keep the wings level and place the nozzles in hover stop. Check that the nozzle angle is between 81 and 83 degrees and the flaps have programmed to 62 degrees. Maintain AOA below 15 units.
Altitude.
Place the witch's hat on the horizon and use your throttle to maintain the shallow glide slope of 3 degrees. Aim the aircraft for a position of 150 feet AGL above the pad and slightly offset to one side. This will allow you to keep good sight of it. At 60 knots, with the velocity vector on the horizon and wings level, you should see no more than 2 legs of the power hexagon. Although this may not guarantee performance enough for hover and landing depending on environmental factors. If you see more than 2 legs, you are too heavy for your power available. Initiate a wave off with full power, perform an accelerating transition, and reset to the key.
Water.
When your speed falls below 50 knots, a large power addition may be needed due to the loss of wing lift. Control closure to the pad to less than 30 knots by making small pitch adjustments, and keep the vane centered using the rudder. Trim the aircraft as necessary to minimize your workload.
Really bad mission. It's just a mess. I have only 20 pounds of water and I'm pretty high.
When the pad is on a 45-degree bearing from you, begin your cross to the pad by lowering your wing in its direction. When you are directly over it, flare slightly to stop and establish a stabilized hover. When you are ready, reduce power slightly and descend to 50 feet AGL in a stabilized hover. Once you are in a stabilized hover at 50 feet AGL over the landing point, you may initiate a vertical landing by reducing power slightly by 1 to 2% and establish a rate of descent between 300 and 400 feet per minute. You may need to re-add throttle to capture this rate of descent and reduce throttle as you enter ground effect, which is about 5 to 10 feet AGL. Alternatively, in high winds greater than 10 knots, you may need to increase throttle in ground effect to counter an apparent suck-down effect. When you touch down, bring the throttle to idle, apply the brakes, set the nozzles fully aft, turn the water switch off, and trim the nose to 4 degrees down. This covers the vertical takeoff and landing training mission.
Yeah, so really dangerous mission. I guess it can be done, though the biggest problem is...
There's an old saying in aviation that goes, any landing you can walk away from is a good one. That is a bunch of garbage, a bunch of feel-good nonsense. If you've ever seen the price tag on some of these parts you're bending on my aircraft while you're trying to learn how to land it, it may actually be logical to not walk away from these landings anymore. Just think about it.
Very philosophical.
Caution.
So, yeah, the key point is wrong coming from that waypoint there to the key, from the waypoint 1 to the waypoint 2, which is the key, and then basically completely messed up. I don't know if he said something about turning or something. It's just yeah. Okay, let's turn off the engine.
Caution, caution. Limiter off. Fuel control generator.
That will do. Still, it needs a lot of practice to master it. We'll see the next missions, how they go.